Hello everyone, welcome to Unique World Education Dubai YouTube classes. Here I am working as mathematics faculty. So today we are going to explain one very important topic in your upcoming JEE exam as well as your board CBSE board exam, that is linear differential equation. Okay. So linear differential equation, basically it is introduced by very famous mathematician Lagrange. So this differential equation is also name it as Lagrange's linear differential equation. Okay, so Lagrange's linear differential equation as well. So let me explain the concept for first. Okay, so a differential equation can be represented in the form of dy by dx plus py equal to q. This is called linear differential equation. So, but we are having some certain set of condition here. The condition we are having, p and q are in terms of x. If I am considering this differential equation, it is necessary to have p and q are in terms of x. And one more condition we are having, if it's not x, it will be some constants. Okay. So p and q are in terms of x, or it can be constants as well. And the second condition we are having, coefficient of dy by dx. As you know, as per this general format, coefficient of dy by dx must be 1. So if a differential equation you are getting in this format, dy by dx plus py equal to q, we have to solve this differential equation by applying the formula, that is y into integrating factor, that will be equal to q into integrating factor dx. So your doubt is, what is this if, what is this integrating factor? So this if, as I told, it is called the integrating factor. So integrating factor of this kind of differential equation can be calculated by the formula e to the power integral of p dx. Okay, so these three things you have to remember. So a differential equation can be represented in the form of dy by dx plus py equal to q is called Lagrange's linear differential equation. Condition we are having, p and q are in terms of x or constant. Coefficient of dy by dx, as you know, that will be equal to 1. So we have to solve this by applying the formula y into integrating factor, that will be equal to q into integrating factor dx, where integrating factor equal to e to the power integral of p dx. Okay, so this topic is very much important for your upcoming exam. So let's clarify all this concept with the help of one example. Yes, so this example is nothing but it's a previous year JEE Mains question. So this is the previous year question that asked already in 2019. So we have to solve this. Okay, so the question is the solution of this differential equation, x into dy by dx plus 2y equal to x square, where initial value condition they given y of 1 equal to 1. So let's start solving this for your better understanding of this concept. So x into what differential equation they given? They given x into dy by dx plus 2y, that will be equal to x square. So if I am comparing this with our standard equation dy by dx plus py equal to q, it is not in standard form, so we have to make into standard form. So if you, in order to make this equation into standard form, coefficient of dy by dx in the standard form, it is 1, but in this question it is given x. So if you want to make this into standard form, simply you have to divide the complete equation with the x. So what will happen here? The first term, if I am dividing with x into dy by dx, when I am dividing with x, that will be only dy by dx. Yes. Plus second term 2y is there. If you are dividing with x, it will become 2y upon x. Then third term we are having x square. So x square, when I am dividing with x, it will become x. Now we can compare with the standard equation dy by dx plus py equal to q. Then p and q are in terms of x. Yes, p and q are in terms of x. So as per comparison, we can write p will be equal to 2 upon x and q will be equal to x. Okay. Now I told we have the formula, what we are having the formula, y into integrating factor, that will be equal to integral of q into integrating factor dx. So in order to solve this, the first and topmost priority thing is integrating factor. So we know how to calculate integrating factor as well, e to the power integral of p dx. So this will become e to the power integral of p is 2 by x. So 2 by x dx will come. So if I am taking this 2 outside, it will become e to the power 2 into integral of 1 by x log x. Now that we can integrate very easily e to the power 2 integral of 1 by x dx, that we know that is log x. So e to the power 2 log x we are having. So what we can write from here? We can write directly by applying the relation a into log m, that we know a into log m, that will be equal to log m to the power a. So e to the power 2 log x, I can write e to the power log of x square. So e and log we know they will be cancelled, directly cancel each other. So we can directly write here. So the integrating factor of this differential equation is nothing but it is x square. So after getting integrating factor, your task is very easy. Just apply in the given differential equation or given solution of this differential equation. So y into integrating factor. So y is y itself into integrating factor. Now we calculated, that is x square. That will be equal to integral of q into integrating factor. So q is x into integrating factor is x square dx. Now if I am just integrating, what will happen? Y into x square, that will be equal to x into x square, we can write x cube dx. Okay, so as you know, integral of x cube will become x power 4 divided by 4. Don't forget to write the constant of integration because initial value condition is given. Okay, so y of x square equal to x power 4 divided by 4 plus constant of integration. So from here I can write y will be equal to x power 4 divided by this x square I am transposing. So it will become 4x square plus c I am having transposing this x square. So it will become cx square, c by x square. So the simplified form of the solution of this differential equation is y equal to x square and x power 4 I can cancel. So x square divided by 4 plus c divided by x square. Now we want to find the particular solution by applying the initial value condition. So initial value condition they given y of 1 equal to 1. So y of 1 equal to 1, it is nothing but when value of x equal to 1, y will be also equal to 1. X equal to 1, y equal to 1. That is the meaning of y of 1 equal to 1. So in this solution, what we are getting here right now, y equal to x square upon 4 plus c upon x square. If I am substituting this initial value condition here, so this will become 1, this will become 1 by 4 plus this will become c. C by 1 square, that is c itself. So from here c I can write 1 minus 1 by 4, that will be equal to 3 by 4. So this 3 by 4 is the value of constant in this integration. So if you are getting the value of constant c, just substitute back this c in your general solution. So what we are getting here, y equal to x square divided by 4 plus c divided by x square. So c value is 3 by 4. So if I am substituting this 3 here, so this will become 3 divided by 4x square. Now if I am just observing the option, clearly we got the answer, that is option D is the correct. So y equal to x square by 4 plus 3 divided by 4x square is the solution of this given differential equation. How simple it is, right? Just we have to understand the standard form and we have to understand the formula itself. Okay, now for boosting your confidence, let's go for one more question. Okay, so yes, this also the previous year JEE Mains question. So let me read the question first, then we can go for the solving part. So let the solution curve y equal to y of x of the differential equation 1 plus e power 2x into dy by dx plus y equal to 1 passes through the point 0 pi by 2. Then limit extends to infinity, e power x into y of x is equal to. So don't worry, the task is very simple. They are given the differential equation. The differential equation what they are given, 1 plus e power 2x into dy by dx into dy by dx plus y equal to 1. This is the differential equation is given, and they are telling we have to find some condition. This is nothing but it is a solution of a curve y equal to y of x. Solution of a curve is given. If we are finding the solution, it will go back to the solution or solution of the curve. If we are if we are finding the solution of that differential equation, it will go back to the equation of the curve, right? So basically we want to find the solution of this differential equation. We want to find the solution of this differential equation in this case. Okay, and we have to apply the condition. This curve is passing through 0 comma pi by 2. So we have to apply the condition after finding the solution. Then we have to apply the limit. Limit is normal. I think it's very easy. We have to apply directly as well. Okay, so 1 plus e power 2x into dy by dx plus y equal to 1, it is given. So if you want to write this into standard form, how I will make into standard form? Yes, got this idea. So dy by dx plus y, that will be equal to 1 divided by 1 plus e power 2x. That's nice. Dy by dx plus y equal to 1 divided by 1 plus e power 2x. Now if I am comparing this with standard equation, dy by dx plus py equal to q. Yes. So p and q are in terms of x or constant term, as I told. So here when I am comparing with the standard equation, p will be equal to coefficient, that is here I am having, that is 1. Nothing is there. So dy by dx plus y means coefficient of y is nothing is there. That means here we are having 1. That is not in terms of x. No problem. And what about q here? Q will be equal to this term that is in the RHS part, that is 1 divided by 1 plus e to the power 2x. That's fine. Now before solving, we can first find the integrating factor, as that one is topmost priority. So integrating factor, that will be equal to e to the power integral of p dx. So this will become e to the power integral of p is 1. So 1 dx, that you are getting e raised to 1 dx is that 1 dx integral is nothing but e raised to x. That's it, integrating factor. So after finding integrating factor, just go for the solution part, that is y into integrating factor, that will be equal to integral of q into integrating factor dx. Q into integrating factor dx. So y into integrating factor, so y is y itself into integrating factor is e raised to x, that will be equal to integral of q. What we are having? Q we are having 1 divided by 1 plus e raised to 2x into integrating factor we are having e raised to x dx. Now if I am just integrating this thing, what will happen here? Y into e raised to x, that will be equal to, okay, let me write it in standard form. So e raised to x divided by 1 plus e raised to 2x dx. Now how to integrate this thing? If you are observing carefully, you can understand this. You can easily integrate by the method of substitution. So here I am going to substitute, in the integration part I am going to substitute e raised to x as t. So if I am substituting e raised to x as t, so we know after differentiation e raised to x into dx, that will be equal to dt. So numerator part, if you are observing, that will be dt. So if I am writing that thing here, y into e raised to x, that will be equal to, numerator is e raised to x dx, that is dt, divided by 1 plus e raised to 2x. So e raised to 2x, what we are having? E raised to 2x means e raised to x is t. So e raised to 2x will become t square. Yes, now it is in the standard form. 1 divided by 1 plus t square. That obviously that is tan inverse t. So I can write y into e raised to x, that will be equal to tan inverse t plus constant of integration. Now resubstitute this t back. So y into e raised to x, that will be equal to tan inverse of e raised to x plus constant of integration. So y into e raised to x, that will be equal to tan inverse of e raised to x plus c. Now just I am going to substitute the initial value condition. They are telling this is the curve basically, y into e raised to x, that will be equal to tan inverse e raised to x plus c. So this curve is passing through the point 0 comma pi by 2. Yes, that's fine. So y into e raised to x equal to tan inverse of e raised to x plus c is passing through 0 comma pi by 2. So if I am comparing this with 0 comma pi by 2 with the corresponding x and y values, just substitute here. So y into e raised to x means y into e raised to x value. So x value is 0. So e raised to 0, y into e raised to 0. So y value here we are having pi by 2. Yes, y value is pi by 2. So pi by 2 into e raised to x. So e raised to x means e raised to 0. So e raised to 0 means what we are having, that is 1 itself. So pi by 2, that will be equal to tan inverse of e raised to x. So tan inverse of e raised to x, we are having here x is 0. So x is 0 means here it will become e raised to 0. Anything to the power 0, that we know that will be equal to 1 plus c. Alright. So pi by 2, that will be equal to tan inverse 1, we are having pi by 4. So pi by 4 plus c. From here we can write c will be equal to pi by 2 minus pi by 4. That will be equal to pi by 4 itself. So constant of integration we are getting, that will be equal to pi by 4. Just substitute this c equal to pi by 4 here. I am writing in y into e raised to x only. Why y into e raised to x? If you want this y into e raised to x, that will be equal to tan inverse of e raised to x plus c. They clearly mention y equal to y of x. So instead of this y, you can write y of x as well. So y of x into e raised to x, that will be equal to tan inverse of e raised to x plus c. So constant of integration what we are having, pi by 4. Just I am substituting pi by 4 here. So y of x into e raised to x, that will be equal to tan inverse of e raised to x plus constant of integration, that is pi by 4. Now you have to do one thing. They are telling we have to find the value limit x tends to infinity e raised to x into y of x. Yes, so here we are having this e raised to x into y of x. So we want to find the limit for this function. So if you want to find the limit, so limit x tends to infinity e raised to x into y of x, that will be equal to just apply the x tends to infinity in this RHS part. So this will become basically tan inverse of infinity e raised to infinity plus pi by 4. So if I am simplifying this thing, what we are getting, tan inverse infinity, that we know that will be equal to pi by 2 plus pi by 4. If I am taking LCM or cross multiplication, whatever you do, for pi plus 2 pi 6 pi. So 6 pi divided by 8 we will get. So 6 pi by 8, that will be equal to 3 pi by 4. So that means basically the condition limit x tends to infinity e raised to x y of x, that will be equal to 6 pi by 8 or 3 pi by 4 is the solution. So option B is the correct answer for this question. Okay, so this is the two question recently asked in your JEE Mains exam, and lots of question definitely it will come for your board exam as well. Okay, so for boosting your confidence, I am giving you one more question for solving the same way of linear differential equation, that is 1 plus x square into dy plus 2xy dx equal to cot x dx. You have to solve this equation and put your answer in comment section. Okay, so thank you so much for watching this YouTube classes of Unique World Education. If you are having any doubts, you can put your doubts in comment section, and that's all about today's session. Thank you so much.